Dear students, today I would like to explain halogen compounds, organic halogen compounds. They are generally represented by Rx. The IUPAC name of the halogen compounds is known as haloalkane. Haloalkane. There should not be a space between the halo and alkane. And the commercial name, we always let us write the commercial names within bracket. It's known as alkyl halide. Known as alkyl halide. Now, they can be classified. Let's see how these halogen compounds are classified. Classification. Primarily, they are classified into primary, secondary, and tertiary halides. A primary halide has got a CH2X. So the general molecular formula of primary halide is going to be RCH2. It is called primary halide because the halogen is attached to primary carbon. A primary carbon is a carbon which is attached to one more carbon. The same way, the secondary halide has got CHX. It is so called because halogen is attached to secondary carbon. Again, a secondary carbon is a carbon which is connected to two other carbons. The same way, you have a tertiary carbon. If the halogen attached to a tertiary carbon, it's called tertiary halide. Okay. The primary halide, again, can be classified into the one which is attached to sp3 carbon. The one which is attached to sp3 carbon. Let's see. This again can be classified into alkyl halide, primary alkyl halide, or allyl halide. Allyl halide. The second one is going to be, the third one is going to be benzyl halide, depending on the nature of the group. What is an allyl halide? As this CH2 double bond CH2 CH2 dash is called an allyl group. If you have a halogen, it's called allyl halide. If you have OH group, allyl alcohol. If you have NH2, it's called allyl amine. Okay, now let us take the halide. Again, the halogen can be any halogen. Fluorine, bromine, and iodine. But among these four halogens, normally we use only three halogens: alkyl chloride, alkyl bromide, and alkyl iodide. We rarely see alkyl fluoride in any textbook. If any of them is used as alkyl halide, normally they would have used either alkyl chloride, alkyl bromide, alkyl iodide. In terms of the reactivity, alkyl iodide is going to be most reactive than your alkyl bromide, than your alkyl chloride, than your alkyl fluoride. Alkyl fluoride. Now let me tell you why alkyl fluorides are not found in the textbook. For two reasons. Number one, preparation of it is strenuous. It's very difficult. Supposing you want to prepare methyl chloride. How do you prepare methyl chloride? You take methane and chlorinate it in the presence of light. Same way, you take methane and brominate it in the presence of light. Iodine also to some extent is possible, but it is reduced. Similarly, it is not easy to prepare methyl fluoride by taking methane and fluorine, because we have already done this experiment with regard to methane and methyl chloride. Now, if you are going to enter into the lab and start preparing methyl fluoride thinking that you would get this, you are not going to get methyl fluoride. On the contrary, you are going to get carbon and HF because of very high affinity towards hydrogen atom by fluorine. And are we going to prepare carbon by this method? Definitely not. Another more interesting reason is direct fluorination is going to be highly exothermic, highly explosive. It explodes. So one has to be very careful in preparing the fluoride. Fluoro compounds cannot be prepared directly. So we have to take lots of precautions to prepare this molecule. Even though you have spent your time and energy to prepare this compound using controlled reactions, at last you are going to find that alkyl fluorides are going to be useless compound, because in terms of reactivity, alkyl fluoride is going to be least reactive. So definitely we are not going to waste our energy and money to prepare the alkyl fluoride. Therefore, whenever we say alkyl halide, either we refer to alkyl iodide, alkyl bromide, and alkyl chloride. Though alkyl iodide is going to be most reactive, most of the places alkyl chlorides only are used, because in terms of the cost factor, alkyl chlorides are definitely cheaper when compared to alkyl iodide. So we have to strike between the cost factor and the percentage yield. Therefore, most of the reactions found in the textbooks are made use of alkyl chloride, but you can use to understand the reactions any of them. Okay. Now, this allyl chloride is going to be another primary halide. Let me give you an example of benzyl chloride and benzyl iodide. What is the benzyl group here? Benzyl group is going to be C6H5 CH2 dash. This is called benzyl group. Supposing you put a chlorine here, benzyl chloride. Bromine here, benzyl bromide. Okay. In fact, benzyl fluoride, benzyl bromide, and benzyl iodide are themselves IUPAC name. So they are the IUPAC name of this. Okay. How do you name this compound as a derivative of benzene? Okay, let's go into the nomenclature part of it also simultaneously. This is benzyl chloride. Or another name, you try to take this as the reference point, 1-carbon alkane. What is 1-carbon alkane? Methane. And what are the groups attached to that? Iodine and phenyl. And you have to name them according to the alphabetical order. So I comes first. So iodo, phenyl, methane. You don't need to say 1 iodo, 1 phenyl, because already it's understood there is only 1 carbon atom. Or how would you name this as a derivative of benzene? Okay, they can ask you this particular question in other competitive examination. So you should be able to know the names by different method. Okay, how would you name this compound as a derivative? Now tell me, what is this particular compound? We know this is going to be toluene, okay, or phenyl methane, or as a derivative of benzene, this is going to be mentioned as methyl benzene. This is going to be methyl benzene. Since this is methyl benzene, please remember, you are not supposed to leave a gap between methyl and benzene. It's a single word. Therefore, how would you name this compound as a derivative of benzene? Now, in the place of supposing you say there is no iodine here, if it were to be methyl benzene, this is not methyl, this is iodomethyl. Iodomethyl. Therefore, what is the name here? Iodomethyl benzene. That could be another IUPAC name. Okay. So that is going to be benzyl halide. Okay. Now, having seen some of the, now let us see halogen attached to a secondary carbon, sp2 carbon. Halogen attached to an sp2 carbon. We saw halogen attached to sp3 carbon. sp2 carbon, it is going to be CH2 double bond CHX. Let me put chloride. And what is this compound here? Chloroethene. This is going to be chloroethene. What is the commercial name? Very important compound. This is going to be vinyl chloride. Vinyl chloride. Now you know vinyl chloride is going to be a monomer for the preparation of polyvinyl chloride. PVC. The famous PVC is prepared from this compound. In that context, this is commercially, industrially an important compound. Chloroethene. Okay. Next one, sp. Halogens attached to sp carbon atom. This is going to be CH triple bond CCl. Chloroethine. This is going to be chloroethine. Chloroethine is going to be the IUPAC name here. Okay. Having seen the classification of halogen compounds, now let us see how these halogen compounds, alkyl halides, are prepared, general methods of preparation of alkyl halides. Of course, one can go in detail about the nomenclature of halogen compounds also. I want to specify here that besides the IUPAC name, you should also know some of the important commercial names or trivial names, especially for the first 4 carbon atoms. And of course, this is going to be chloromethane. Let me take only chlorine. Chloromethane is IUPAC name. Chloromethane is going to be the IUPAC name. And what is going to be the commercial name here? Methyl chloride. This is going to be methyl chloride. Same way, methyl chloride. Now, let me take C4 carbon atoms. Or to start with, C3 carbon atoms. C3 carbon atoms. Now, let's see how many isomers are possible. What should be the general molecular formula of an alkane? C3H8. Supposing you take a monohalogen derivative, it should be C3H7Cl. Now, this is going to be another important question for you for all the competitive examinations. How many isomers? They can ask you the number of isomers. Given the molecular formula, they can ask you to identify the number of isomers. How do you find out? Now, for that, you write the skeleton. Having written this, in how many places you can put one chlorine? I can put one chlorine here. That is going to be compound number 1. I put one more chlorine here. That is going to be compound number 2. By putting a chlorine, the same as this. So I am able to get 2 compounds, namely, okay, let me try to write these things also. Number 1 is going to be CH3, CH2, CH2, Cl. If you are going to put a chlorine in the middle carbon, it is going to be CH3, CHCl, CH3. And of course, one has to give the IUPAC name as well as the commercial name. IUPAC name is 1-chloropropane. IUPAC name is 2-chloropropane. Commercial name is N-propyl. This is called N-propyl chloride. This is called isopropyl chloride. Okay. Now, you should also be knowing how to write the bond line formula, because these days the molecules are always represented by bond line formula. Bond line formula. I'll tell you the important bond line formula. Now, how do you write the propane? This is going to be propane. Now, I am going to have a chlorine here. So, this is going to be the bond line formula of compound number 1. What should be the bond line formula of the compound number 2? You write this. This is going to be a propane. Now, you have a chlorine here. You should write upward only, because you should not write chlorine this way. You should write this chlorine. You have to represent the tetrahedral, because this is going to be CH3 here. This is going to be a carbon here. This is CH3 here. Now you have got one hydrogen. So look at this structure here. It's a perfect tetrahedron. That's why you are supposed to put the chlorine on the top. Okay. Now let me identify the various isomers for C4 alkane. For C4 alkane, what should be the molecular formula? C4H9Cl. It is going to be the chloro derivatives of C4 alkane. C4 alkane is C4H10 butane. Okay. Now, how many isomers are possible? Number of isomers. Now, you should be able to do all these things with the shortest period of time. And you should know how to identify this. You should be able to visualize this also. Now, the fastest way of identifying the number of isomers, how many possible skeletons are there for C4? One is going to be the normal skeleton, which is represented by this bond line formula. The another one is going to be the branch chain, which is represented by this is the bond line formula. Having mentioned this, now we find out in how many ways you can put one chlorine. Okay, as usual, Let me put one chlorine here. Let me write the bond line formula later. I can put chlorine here. Putting chlorine is same as this. Putting chlorine is same as this. With the normal chain, I can prepare two isomers. Now with the branch chain, let's see in how many places I can put one halogen atom. I can put here, and that is going to be compound number 3. I can put one chlorine here. That is going to be compound number 4. Putting a chlorine here, same as this, same as this. You can do it. You can go home and put chlorine here, write the IUPAC name. Put chlorine here, write the IUPAC name. Put chlorine here, write the IUPAC name. And in all the 3 cases, you are going to get the same IUPAC name. That is why putting a chlorine here and here and here are all the same. Okay. Now, this is going to be 4 isomers. You have to be very careful here. There is a tag here. There are going to be 4 isomers without taking into consideration the stereoisomerism. Now, if we are going to take into consideration the stereoisomerism also, now look at this. See here very carefully. By putting a chlorine here, shall I write here compound number 1? CH3, CH2, CH2, CH2Cl. And none of these carbon atoms are an asymmetric carbon. Therefore, it is not optically active. So, compound number 1 has got only one isomer. Now, let us take compound number 2. Let me put the chlorine in the second carbon atom, CHCl and CH3. By putting a chlorine in the second carbon atom becomes asymmetric center. It becomes an asymmetric center. Therefore, being an asymmetric center, okay, let me write that particular molecule here, compound number 2, CH3, CH2, CHCl, and CH3. Look at this. How do you say what is an asymmetric center? It is carbon attached to 4 different atoms or groups. Now let's see here. We have got one hydrogen here, one chlorine here, one methyl group here. The other one is going to be ethyl. So any carbon possessing 4 different atoms is called an asymmetric atom. If a molecule contains at least one asymmetric center, that particular compound should be optically active. What is the meaning of this? It is going to turn the plane polarized light towards right or left. It's a separate chapter by itself. Now let me say that there are going to be 2 compounds. One is called dextrorotatory, the other one is called levorotatory. Therefore, compound number 2 is resolvable. That is the term we use. When I say resolvable, it can be separated into D and L. That means when you try to chlorinate the butane, if you are going to get chlorine in the second carbon atom, it can be again be separated into D compound and L compound. So there are going to be 2A and 2B. Now let me write the structure of compound 3. Now you tell me whether the compound 3 is going to be optically active. CH2Cl. Is it optically active? No. It has got 2 similar groups over here. Therefore, it is not optically active. Therefore, that is going to be one compound. The 4th compound, again, it has got a methyl group here, a methyl group here, a methyl group here. Definitely, it is not optically active. So, altogether, now you count the total number of isomers. 1, 2, 3, 4, and 5. So, how many isomers are possible when butane is monochlorinated? 5 isomers, taking into consideration the optical activity. Without optical activity, it is going to be only 4 isomers. Now, in the answer question paper, either you will have number 4 or number 5. You have to be very careful about this particular answer. So, that is one way of identifying the number of isomers. Maybe you can go home and what should be the total number of isomers for C5? What is the C5 alkane here? C5H12. C5H12. Now, remove one hydrogen atom by a bromine. This time, let me add bromine here. C5H11Br. Now, how do we go about finding out the number of isomers, total number of isomers? How many skeletons are there for C5? I told you C4 has got 2 skeletons. C5 has got three skeletons. Number A, it is going to be normal skeleton. B, it is called 5 plus 0. The second one is called 4 plus 1. That means 4 carbon atoms in a straight chain and 1 branching. The other one is called 3 plus 2. That is, you have 3 carbon atoms in a straight chain and 2 in the branching here. That is, the one has to find the total number of isomers, carbon skeletons. Okay. Having got this carbon skeleton, you can put a chlorine here. You can put a chlorine here. You can put a chlorine here. Compound number 1, compound number 2. We'll quickly go through the IUPAC nomenclature here. If you are going to put bromine here, it is 1-bromopentane. If you are going to put bromine here, 2-bromopentane. As usual, 2-bromopentane is going to be optically active. That is going to be resolved into dextrorotatory and levorotatory. And this is going to be 3-bromopentane. And 3-bromopentane, definitely it is not optically active because it is not an asymmetric center. Because you have got an ethyl group here, another ethyl group here. And now let us see. Now you tell me how many isomers are possible in the skeleton. Start putting it. Okay, let me put a bromine here. I'll call this as compound number 4. Compound number 4. Now let me write it. Compound number 4. And I can putting a carbon bromine here. It is also same as this. I can put a bromine here. I can put a bromine here. I can put a bromine here. Now, shall we call this as compound number 5, compound number 6, compound number 7, and compound number 8? Compound number 8. Now, how many isomers with the skeleton? Without geometrical isomers, without stereoisomers, only 4 isomers. 5, 6, 7, 8. But including stereoisomers, how many isomers? Now, there are going to be 6 isomers in that. Are you able to visualize that? Now, let's see. Let me write compound number 5. Compound number 5 is going to be CH3, CH2. This is the carbon skeleton. You had CH3 here. Now, one of the hydrogen atoms substituted by bromine here. Now, please remember, by converting the methyl into methyl bromide, the second carbon atom automatically becomes an asymmetric center. You don't look at always this. This is not going to be an asymmetric center. By converting this into a CH2Br, this becomes automatically a symmetric center. Therefore, compound number 5 is going to be resolvable, D and L. Okay? Now, by putting a chlorine here, it is not an asymmetric center because we have got a methyl and methyl. As usual, by putting a bromine here, it is going to be resolvable, D and L. So, how many isomers you have got? Compound number 5 is resolvable, gives you 2. This is the third one. This again is going to be resolvable, 5 here. This is going to be 6 here. And that is going to be another important question for your IIT here finding out. And the last skeleton. What is the last skeleton here? I told you this is going to be neopentane. Now, all of them are going to be identical. CH3, 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 CH3. You try to replace it one hydrogen atom by chlorine. It's same as putting a chlorine here, same as putting a chlorine here. So, how do you name the IUPAC name here? You take the longest chain. Longest chain contains how many carbon atoms? 3 carbon atoms. Therefore, it is going to be, you have a chlorine in the first carbon atom, and there are 2 methyl groups. Which should you name this? Chlorine, 1-chloro, 2-2, 2-2, dimethyl propane, 1-chloro, 2-2-dimethyl. If it is going to be bromine, 1-bromo, 2-2-dimethyl propane. That is called neopentyl bromide. Commercial name, neopentyl bromide. Commercial name. Now, why I wrote this? Because this could be asked in a different format, the question. They can ask you to identify the total number of isomers, or they can, given the commercial name on one column, they can give you IUPAC name on another column. They can ask you to match. For example, now let us see. The IUPAC name we know. This is going to be 1-chloro, 2-methyl propane because the longest chain has got 3 carbon atoms. But what is going to be the commercial name? Commercial name is going to be isobutyl. This is called isobutyl group. If you have chlorine, isobutyl chloride. If you have OH, isobutyl alcohol. If you have NH2, isobutyl amine. Similarly, this is going to be tertiary butyl. This is going to be tertiary. All the commercial name, please note, you try to put it, be in the habit of putting it in bracket. Anything put in the bracket is not an IUPAC name. Of course, it's not a rule. It's a rule that we have created. And this is tertiary butyl chloride. On one column, they will have tertiary butyl chloride, and one of the names is going to be a IUPAC name. You have to correctly match. What is the compound here? The longest chain has got 3 carbon atoms, therefore 2-chloro, 2-methyl. Propane is going to be the IUPAC name. So, and what is going to be the IUPAC name? 2-chlorobutane. And what should be the commercial name here? They can ask you. And it would be given as S-butyl chloride. What is S-butyl? Secondary butyl. And what is the commercial name? N-butyl chloride. And the IUPAC name is going to be 1-chlorobutane. So we have so much of information in the classification of the alkyl halides and the isomerism of an alkyl halide. They are very important. And of course, the general methods of preparation of alkyl halides, the reactions are also is going to be a very big chapter. Probably we shall take up that next class. Okay, thank you.